Welcome to clickmyproject.com. The project entitled is NETWRAP and NDN based on real-time wireless recharging framework for wireless sensor network. It's based on mobile computing platforms. And this is abstract. In this abstract, mainly motivate to using vehicle equipment with wireless energy transmissions technology to research sensors over the air as a game changer and traditional wireless sensor network. The research policies regarding when a resource without sensor nodes is critically impact the network performance. So far, only a few works had to study such as researching policies for this case of using a single vehicle. In these papers, we propose a NETWRAP and NDN based real-time wireless recharging protocol for dynamic wireless recharging in sensor network. A real-time recharging framework supports a single or multiple mobile vehicles. Employs multiple mobile vehicles provide more scalability and robustness to efficiently deliver sensor energy status information to vehicle to real-time leverage of conceptual mechanism from their network and design energy monitoring and reporting protocols. We derive theoretical results on the energy neural conditions, the minimum number of mobile vehicles required or perception network operations. Then we study how to minimize the total traveling cost per vehicle while considering all the sensor nodes can be recharged before their batteries die. So next we move to architectures of process. First start the process and communicate with WSN data. After that we get the energy interest message from the sensor node and head node, and finally subscribes the directory of energy information from the sensor. Finally end the overall process. Next we move to execute the process. This is a home screen. In this home screen we enter the globe. After that we selected the particular data set in our process. This is a data set, so we have to select the sensor code data sets based on the process. This is creating the node, and after that we're creating a sensor based on communications process. And this sensor is created from the wireless sensor network based on a rate charging framework in NDN framework. After creating this process, and this process successfully completed for every node from our sensor node. Here sensor node successfully created from here. After that we get the number of nodes and battery charging level based on our normal energy intensity propagation. After we get the sensor results from the battery charge based on real-time wireless recharging framework. Based on that, this wireless sensor network, this is we processed completed here. This is a base simple performance for the average overhead. This is energy overhead for node in M. This is time horse. This is taken time horse for this process. The next process is extract node from the source and destination. In this source we get the node recharge performance. This is general performance. So in this final performance, it's a source the node and energy time horse emergencies based on load communications in evaluation emergency based on battery charging. And next energies, this gives head cluster node energies and based on related node for normal node and performance about the energy neurals. Based on that energy neurals we get the implementing for particular perception here. After that we communicate the process. The entire energy will be produced based on time, based on hours. It's taken hours, and in this energy neurals is n equal to 500 and s equal to 50 based on this process communicated with that sensor. After this head node is communicate with this and a normal node communicate this, we get the proxy communications from the minimum weights of heuristic algorithm and complexity analyzing. After the send calls and shortest path and node time seconds will be displayed in this sensor ID, battery status and distance will be produced in normal node to head node. Next we move to NDN based on real-time wireless recharging protocol. In these protocols there is a source node, destination node, battery status, distance, optimal time, head node and proxy node and service stations based on sensors. Now we get the customer route extracted from the sensors. After that we give the optimal time and we get the simulation result from proxy head and head node. If the service station and proxy head result is same, the process is successfully completed here. This is a node. After that in this node communicate between a null point is not display our main process. After that we getting proceed from this. This is the settings for the field length. These are values, our values, and based on battery capacity and send core speed and simulation month. And next traveling distance, non-functional nodes. It will be produce the non-functional perceptions based on how the percentage of non-functional percentage. And this is a function based on non-functional statistics. When the process is successfully evaluating the non-functional communication. And response time, this is the average response time. And network size, in this network size is aligned to analyze amplitude based on frequency communication. These are load fractions, it's based on evaluations from the load balance to milliseconds and sense cost and number of sense costs proceed to the balance of load to sense cost. This is a performance for load, and this load to mileage of sense gas and mileage of kilometer. In this duration, how it will be possible to run a mileage based on our sensors. And this is a recharge programming problem formulation. Now level 1 we provide some of user inputs, like this is our input, and in this level we providing some of the head nodes. First we get the normal node. We as in the speed, the core will be moved from the based on the process. We're just comparing the every nodes from the 1 and 34 and 3, 34 and 43 and 43, 34, 43 to 34, 43 to 3, and next it's compared to 1 to and 3 and 3 and 44, 34 and 2, and final 1 and 3, 3 and 2, 3 and 34, 34 and 2, and 34 and 33 and 34 and 3. So finally its comparison is completed and the process is completed here. Final process is 34 and 3, 1 and 2, 2 and 2, 2 and 3 in the procedures following steps like 2 and 2, 2 and 2 based on core movement. Every process is successfully completed. Next head node, we get the speed. This process compare with X and Y. It's a comparison of X and Y. Like this process is assigned to X and Y, like the X assigned to 450 and 6. This assigned to speed compared with the every maximized process. Next we click the proxy, we assign time. Again the compare the minimum and maximum. For that compare 34 with minimum 1 and 3 and minimum 1, 43 and minimum 1, 34 and minimum 1, and final 43 and minimum 2, 34. It's just comparison for every process by step node, core and recharging problem formulation. Here we apply the heuristic performance is based on well-known heuristic communications between our every nodes based on the sensors. Every process is running, still this process is running based on our movement. Again, this is comparing the 34 with minimum 43 and comparing the 34 with minimum level of 43. Every process is successfully completed here. Next, execution time. This is the main important for things. Here we providing some of things. Recharging level will be communicated with based on normal node, with time required based on recharge normal node and head node and proxy node. So head node completed 9.796 seconds, proxy node completed 35.074 seconds, and normal mode it will be recharging. Latest process completed here. This is a final performance. This is existing level of process. This is a proposed level of process. That's all of execution of this process. Thank you for watching.